Hello, and welcome to Creativity and Coding Camp. My name is Audra, and I'm one of the VEX Camp counselors that's going to guide you through learning how to code your very own virtual robots in VEX Code VR throughout this camp. We are going to learn how to do all kinds of coding to be able to make our robots crash castles and navigate mazes and even clean up trash from the bottom of the ocean. I am super duper excited to get started, and I'm sure you are too. So before we dive into VEX Code VR, let's talk about what we need for our creativity and coding camp. It's very simple. All that you need is a device with a Chrome-based browser that we can use to access and launch VEX Code VR. You may want to have a second device with VEX Code VR, or at least a second window, so this way you can see what we're doing in camp as well as VEX Code VR at the same time to make following along with what we're coding even easier. So without further ado, I'm sure you're very excited to get started coding. So let's jump over onto our device so that we can access and launch VEX Code VR. So here I am in my Chrome browser, and all I'm going to type in is vr.vex.com. So once again, that's vr.vex.com, and that's all we need to do in order to launch VEX Code VR. So if this is the first time that you are going to VEX Code VR, you may see a little pop-up like this that'll show you a little bit of a preview of some of the great things that we're going to be able to do with our VR robot. Since we are students, we're going to select this Students Get Started button right here, and that will open up VEX Code VR for us. Now, the first thing that will probably jump out at you right here is you can see a little screen with a tutorial video. So here you can see our virtual robot that we're going to code. This tutorial video will walk you through getting started with VEX Code VR and a little bit about how it works. But since we're going to do that together in this camp session, I'm going to close this window. If you want to open that up a little bit later to watch that tutorial, you can access that one and many others with this little tutorial icon in the toolbar. So now I told you we were going to be coding a virtual robot, and you're probably saying to yourself, Audra, where's my virtual robot? Well, in order to get to our virtual robot, we have to open up a playground. So all of the VR robots live inside of these playgrounds, and that's where we are able to code them to do lots of different things. So the first thing we're going to do in VEX Code VR is select the playground that we want to use. So I mentioned earlier that we were going to crash some castles. So up in our toolbar, we're going to find this button right here that says Select Playground. And we're going to click that, and then you can see all of these different playgrounds. So I'm going to scroll down until I see this one right here that's Castle Crasher. And we are going to open up our Castle Crasher playground. Once you select that, it may take a few seconds for your playground to load, and that's fine. We can be patient. So now once that loads, this is called our playground window. And if we want to move our playground window around, we can. We can just select this little toolbar up here and drag it over to the side if we want to. If we want to make it bigger, we can select this expand button and make it a lot bigger. We can also view our playground in a few different ways. So here at the bottom, you'll see our virtual robot. There it is. There's our real VR robot that we are going to code to move around. And also on this field, on this playground, we see a bunch of buildings. These are some castles. Now, they might look a little bit strange to you right now. That's because we're looking at the field from a top-down view. So as though we were all the way on top of the field looking straight down at it like we were in a drone or something. But if we wanted to see those castles in kind of a little more 3 dimensions, we can change our camera view. So over here in the corner, we have a few different camera views. I'm going to select this one that has the little angle on it. And as I'm doing these things and selecting things, I want you to be following along with me. So this way we are building our projects and exploring VEX Code VR together. So now let's select that, and now we can see, whoa, look at those castles come to life. We can see that they're different sizes, they're different heights, they're made up of different kinds of blocks. And if I click and drag on this field, I can turn it around so that I can look around and see all kinds of different stuff. Whoa, look at that castle over there. It's got green blocks in it. I can also take a closer look at my VR robot. So I can zoom and spin it around so that I can see all of the different features that we're going to learn how to use throughout this camp. So something that you'll notice about our VR robot is that it has 4 wheels, it's got 2 motors, and it's got something called a drivetrain. So as we're learning to drive it, we're going to use blocks that are called drivetrain blocks, and that will enable us to drive our robot. So are you ready to see our robot drive? I'm pretty excited to see our robot drive. So let's switch our camera view back to that top-down view real fast, and let's get ready to start coding in VEX Code VR. So in order to make our virtual robot move around our field here to get ready to crash castles, we have to add some code to our project. So this space over here, we see this when started block. That means that when we press the start button, all of the things we attach to that when started block are going to happen. So what do we attach to that when started block? Well, we attach other blocks that tell our robot what to do. So the very first one we're going to try is this one right here that says drive forward for 200 millimeters. So to add that to my project, I'm going to click it and drag it into the workspace and attach it to that when started block. And you'll hear a little click sound when you do that. You'll notice some other things. I'm going to move my playground window down. You'll notice some other things happen when you bring your blocks into your project, right? We see that little gray shadow that tells us our block is ready to be connected. And we'll also see that they fit together sort of like puzzle pieces. So anytime we're going to build a project, we want to make sure that our blocks are clicked together exactly in that stack, so that way our robot will run those blocks. Are we ready to see our robot move? I am. So in order to start our project, we can use the start button right down here in our playground window. So when we press the start button, we're going to see our robot drive forward for 200 millimeters. Ready? Let's start it together. 3, 2, 1, start. There it went. Our robot drove forward. Now you can see we have a little timer here that's still going. And once our project starts, that start button turns into a stop button. So I'm going to press that stop button now to stop that project. And before we do anything else, let's talk a little bit about what we just did. So what we just did was amazing. You just built your very first project in VEX Code VR. So let's talk a little bit about how we control that VR robot. In order to code any robot to do anything, we have to use something called a programming language. And a programming language is simply a set of rules where symbols represent actions. So in this case, the symbol of that block, that was the drive for block, represented the action of driving our robot forward. Now that action that the robot does is called a robot behavior. So as we're coding our robot to do different things, we want to think about the different behaviors we want our robot to do. And then when we want to change those behaviors, we will change the commands or the blocks that we're using in our project. So this way we're working within that programming language in order to tell our robot what we want it to do. So now we saw our robot move just a little bit, but it didn't crash any castles yet. So we probably want to change that behavior a little, right? So let's go back into our project and back into VEX Code VR and talk about how we change that behavior. So our robot only drove a little bit forward, but this castle is still here and I really want to crash it, don't you? So we told our robot to drive forward. That was the right direction, but it didn't quite go far enough. So 200 millimeters only moved it a little bit. So now I'm going to make this number a lot bigger. I'm going to try 3,000 millimeters and let's see how that works. Now, in order to restart my project, I want to make sure that I'm resetting my field and putting my robot back at its starting point. So I'll use this reset button right here. You see this one with the little swirled arrow? So we're going to select that. And now we can see our timer goes back to 0 and our robot goes back to the start. And now let's start our project again and see what happens. There goes our robot. Oh my gosh, it crashed a castle, but wait, where's it going? If I switch the camera view, you can see my robot is just falling. It drove right off of the playground. I'm gonna stop that project and reset it and put him back on the playground. Oh my goodness. Well, apparently 3,000 was way too far. Well, guess what? There's a little secret that I know that I'm about to let you in on. All of the VR playgrounds are 2,000 millimeters tall by 2,000 millimeters wide. So I knew that 3,000 was a little bit far, but that's okay. We're having fun coding. So if we know that our playground is 2,000 millimeters tall, we can see that this castle is kind of right in the middle, right? So it's probably about 1,000, but my robot's starting off not exactly at the back of the playground. I'm gonna guess that we need to go about 800 millimeters, right? That makes sense. Let's see if we can just crash that castle without falling off of the playground. All right, are you ready? If you haven't reset your field, make sure you reset it. And let's start together. 3, 2, 1, start. There we go. And we crashed that castle. If I want to restart it and look at it again from another view, I can see exactly how well we crashed that castle. Look at that. We knocked down one of those blocks. But I bet we could crash it even better. It looks like we have the right distance. But what if our robot was going a little bit faster? Do you think that would make it knock down more blocks or knock them down a little harder? We can change the velocity that our robot is traveling at with a block in our project. So if we look over here in our toolbox, where all of our blocks live, you'll see that there's this block that says set drive velocity. So I'm going to drag that over here into the workspace. So the drive velocity automatically is set at 50%. So that means it's going at about half the speed that it can. But we can make it go a little bit faster by increasing that number all the way up to anything up to 100%. So I'm going to set it to about 75% velocity, see if that makes it go a little faster. Now, when I add this to my project, I want to think really carefully about the order that I'm putting this block into my project. So if I put it after the drive forward, it's only going to speed up the robot after it's done driving. So I want to make sure it goes before the drive forward. And I can order and reorder blocks in my project just by dragging them around. If we want to change a block, we can detach it, we can move them, we can put them in different orders. We can just drag them around within our project and within the workspace in order to do that. If we ever want to delete a block, we can drag it off and bring it back to the toolbox and it will delete our block. So let me put that block back for now. And let's see what happens when we drive our robot at 75% velocity for 800 millimeters. Let's see, do you think that castle is going to get knocked down even more? Let's take a look. I'm going to drive it. I'm going to show it at this angle so we can see real clearly. Oh my goodness, look at that. They almost all fell down. Amazing. Oh my gosh. So we just crashed our very first castle. But there's not just one castle on that playground, right? There's 5 different castles. So I bet you're probably wondering how we could get ready to crash another castle. Well, so far we've just learned how to drive our robot forward. But in order to get around that field, we probably need to learn how to drive it in some different directions, right? So our robot now has driven to that castle in the middle of the field, but I know that there's some other castles right back to where I started, right? So we're probably going to need to drive our robot back to the start and drive it not in forward, but in reverse. So let's go back to our project and I'm going to show you how we can use that very same drive for block to drive our robot in reverse. So I'm going to reset my field here, and you'll notice every time we reset it, it automatically goes back to this camera view, and that's fine. This is a great place to plan our projects. So now we've driven our robot forward. We know it's landed about here. Well, if I want to bring it back to the start so that I can get ready to crash these 2 castles down here, then I need another block in my project, right? Every time we add a block, we're going to add behaviors that our robot can do. So I'm going to drag in another drive for block, and you can drag that in with me. And now we know if it drove forward for 800 millimeters and we want to go back to where it started, we don't want to drive forward again. We want to drive in reverse. So all of these little things that I can change inside of the blocks are called parameters. So I'm going to change that parameter, which is the direction from forward to reverse. Then I'm going to change the distance parameter here to 800 millimeters. So now let's make sure our field is reset. And when we start our project, let's see if we crash a castle and get right back to where we started. We're going to drive forward, we crash, and we came back. So there we are. Now we're ready to crash our next castle. So let's take a look at where our robot is in relation to these other castles. So we have one over here to the left and one over here to the right. We know how to drive forward, we know how to drive in reverse, but how do we turn our robot? Well, there's a few different ways that we can turn our robot. The first one that we are going to explore is turning it in a particular direction for a certain number of degrees. So what does that mean? We know that our robot can drive forward, it can drive backwards. Now, if we were to turn left or turn right, we want to think about how many degrees we are turning. So you may have learned in math class that a right angle is 90 degrees, right? So if I were to turn my body 90 degrees, I would go from facing this way to this way. And that's the way that we want our robot to turn, right, in order to be able to get ready to crash those next castles. So let's go add that to our project. So now I'm going to take this block right here that says turn right for 90 degrees, right? We just said 90 degrees makes that right angle that turns it exactly over. So I want to turn right for 90 degrees. So let's reset our field and run this project again. One of the great things about VR is that we can constantly run our projects over and over again really easily. And now we can see that when we turned right for 90 degrees, our robot is here. It's facing that last castle. So what do we need to do next? What's the next behavior our robot needs to do in order to crash that castle? Well, it's going to need to now drive forward again, right? Because we know that our robot's ready to crash it when it turns right, but we haven't told it to drive forward. So our robot only does exactly what we tell it to do. So now we're going to add another drive for block to our project. We're going to leave that at forward, and we're going to set it for 800 millimeters again, because that seemed to be working pretty well to crash that other castle. So let's reset our project and see if we can now crash 2 castles with this project. We drove forward, we turned around. There we go. Oh my goodness, we crashed that castle so hard it fell off the playground. Unbelievable. Now, what if I wanted to make my robot turn a little bit more quickly, right? We added a drive velocity and we could see that our robot was driving really quickly forward and in reverse, but it turned a little bit more slowly. Well, I have a turn velocity block here also. And just like the drive velocity, our turn velocity is automatically set to 50% when we start. So I'm going to up that turn velocity to 75% and add that to my project as well. And again, I'm going to put it up here so this way we're telling the robot to turn faster before we tell the robot to turn. So now the next time we use this project, it will turn and drive faster. Now, what if I wanted to knock down this castle on the left instead of the castle on the right? Well, in order to do that, I need to tell my robot to turn left instead of turn right. So here in this turn for block, we can change this parameter from right to left. So let's go ahead and do that, and let's test our project again, and now let's see what happens. Robot's going to drive forward, back. Whoa, look at how fast that turn was, and there it goes. It crashed that left castle. Now, I mentioned before that there's a couple different ways to code your robot to turn. So we just coded it to turn a number of degrees from wherever it was. But our goal in this playground is to crash castles. So our robot's constantly driving and crashing into things. And I bet if you have ever walked and bumped into something, you know that it knocks you a little bit off course. Well, if our robot gets knocked off a little bit off course and then turns 90 more degrees from that off course number, it might not really go exactly where we want it to go. But there is another kind of turn block that will always turn our robot to exactly the location we want to go, and that's called the turn to heading block. So let's talk really quickly about what a heading is. So here we can see our VR robot, and it is surrounded by a circle. And this circle has some degrees on it, and these are called our heading. So our heading is always measured in degrees from 0 all the way to 360, all the way around a complete circle. So if we want to do that 90 degree to the right turn that we were just talking about, that would turn to heading 90. But if we wanted to do that same turn left for 90 degrees that we just did, we could turn our robot to heading 270, and that will turn it there as well. So let's go back to our project and change a couple of blocks so this way we can check out this heading situation. So now I'm going to go back to VexCode VR. I'm going to separate out this bottom block, and I'm going to take this turn left block and bring it back to the toolbox and let it go. So now I deleted that block. Now I'm going to grab this turn to heading block and drag it into my project. Now we want to keep that turn to heading 270, so I'm going to change that parameter to 270. And then I'm going to put this drive block back. Now, when I reset my project, let's see if it does the same thing and crash that bottom left castle. So here we go. We drove forward, we came back, we turned around, and we did it. And we crashed that bottom left castle. Now, something that you'll notice about this turn to heading block is that there's nowhere in it that tells it which direction to turn. That's because whatever degree we set that to, the robot will make the decision of which way it needs to turn in order to get to that heading more quickly. So if it's trying to get to 270, instead of going all the way around from 0 to 270 turning right, it will just make the decision to turn 90 because that is the faster route to get to 270. So then we don't have to worry about thinking about left and right when we're coding our robot. So now that we've learned how to drive our robot forward and in reverse, we've learned how to turn it so that we can crash multiple castles. Now we're going to do a little mini challenge together. So far we've crashed 1, 2 castles, but now we're going to try to see if we can crash 3 castles. But not just any 3 castles, 3 specific castles. So let's take a look at the 3 castles we want to crash, and then we're going to build a project together to figure out how to do that. So for this mini challenge, we want to crash these 3 castles that are going diagonally across our screen. So we've already coded our robot to crash this first one, and we know how to crash this second one, so we can put that back. So let's first figure out those 2, then we'll make a plan to go up and crash that 3rd castle. I'm going to make sure I stop this project so my timer can stop and reset my fields. That way I can keep track of what I'm doing. So now if we look at the project that we have so far, we've set our drive and turn velocity to be a little bit faster. We're driving forward for 800 millimeters to crash the first castle and then back. Then we're going to turn to heading 90 so that we can turn to the right and drive forward to crash this castle. So now if we think about the order we're crashing our castles in, we're going to crash this one first, then we're going to crash this one. Now, how are we going to get back here to go crash this 3rd castle? So let's crash these 2 and then see where our robot ends up. So now if we start our project, we're going to drive forward, come back, turn, and we crash that right castle. Well, we can probably go back to the start here, right? And then that'll put us closer so that we can drive all the way up the field and then turn around to get to that 3rd castle. Every time we're making a plan like this, we want to think about the order in which we're doing different robot behaviors, and that order is called a sequence. So we want to make sure that our blocks are in the right sequence to enact our behaviors in the order we want them to happen. So now our robot is here. So we drove forward for 800. Now we need to drive back for 800 to get back to that starting point, right? So we want to drive in reverse for 800 millimeters. So follow along with me to add that block to your project. And then let's see where that puts our robot so we can figure out where we need to turn. So we're going to drive forward and in reverse and then crash that castle and come back. And now we can see that we need to turn back to be facing forward again. Now, since we've crashed a few castles, we probably want to use that turn to heading block to make sure that our robot's not off kilter. And we're going to set that heading to 0 degrees because that will turn it exactly to face forward. So let's run that project again. And here we go. Let's see if our robot ends up exactly where it started and facing in the same direction. It does. Now we know that our whole field is 2,000 millimeters tall, but we're not quite at the back of it and our castle is not quite at the edge. So we're going to add another drive forward block. And we're going to set that to, let's say, 1,600 millimeters. That should take us somewhere around the top of the field. So let's run that part of our project and see if that gets us to closer to where we need to be in order to crash that 3rd castle. We're driving through all of those. Oh, there we are. We are exactly where we want to be. So now we need to turn to the left or to heading 270. So I'm going to add a turn to heading block here and set that to 270. So if we turn left to 270, we'll be facing this way, and I am just so eager to crash that castle. So what do you think we need to add after that? We've turned, now we need to drive forward. And we're going to drive forward for 800 millimeters because that seems to be working out really well for us. So let's reset our playground and see if we crashed all 3 castles. Are you ready? 3, 2, 1, go. And we crashed 1. And we crashed 2. And here we go. Are we going to make it to that 3rd castle? And we crashed 3 castles. Congratulations! We just solved our very first coding mini challenge. Now, as you're looking at the castles on the field and you're looking at how your robot's moving, you might be thinking to yourself, wait a minute, Audra, I think there's another way to solve that challenge. And you would be 100% correct. One of the great things about coding is that we can be really creative with our projects because there are so many ways to solve the same challenge. So we chose, in order to crash those castles, where we crash the first one in the middle, and then the second one in the bottom corner, and then we went all the way up to the 3rd one in the top corner. But what if we change the order that we crash the castles in? That might help us to crash them a little bit faster. It might be a more efficient project. So let's go take a look at another way that we could solve the same challenge. So if we change the order that we're crashing the castles, and we think about where a robot starts on the field, what if we started with this castle down here first? And then I can see that these 2 are in a straight line diagonally across my field. So if I crash this castle first and I start down here, I could probably turn my robot on that diagonal and be able to crash both of these with very few blocks in my project. So let's see if we can make that project together. So I'm going to stop this one and reset my field so I can watch what I'm doing. And now what I'm going to do is I'm going to take these blocks off and I'm just going to put them over to the side to save them. Anything that's not attached to my stack of blocks will not run when I start my project. So even if I started it right now, none of these blocks would run because they're not connected to this when started block. So now if we think about what we need to do in order to turn and crash this castle, we know that we need to turn right for 90 degrees, right? We haven't crashed anything yet, so we can turn right for 90 degrees. And then we need to drive forward for 800 millimeters. So I'm going to make that 800. I'm going to move these out of the way a little bit more. And then when I start my project, let's see what happens. We turned right and we crashed. So now let's pay attention to where our robot needs to turn. So our robot here is facing that 90-degree heading. So if we take a look at our heading diagram, our robot is facing here, right? But we know we need it to turn all the way around past 0, over here, probably about 45 degrees to the left. So if we think about how we want to get our robot over here to this heading this way, we are going to add about 45 degrees to this 270 heading, and that would put us about 315 degrees, right? Because if 0 and 360 is up here, 45 degrees over there, that puts us at about 315. So now I'm going to add a turn to heading 315 degrees. So when I reset my project, let's see if that turns us in the right direction. So I went to the right, I crashed that castle, and there we go. Now you can see that my robot automatically knew to turn left, so we could do this really quickly, and it's facing diagonally across from these other 2 castles. Now, if we didn't want to use turn to heading, and we wanted to just use the turn 4 block, we could do that also. So now we know that our robot is turned right 90 degrees, right? So we need to turn left 90 to get us back to 0, and then add another 45 to get it to turn to the left. So we're going to turn it to the left for about 135 degrees, and let's see if that does the same thing. Since we've only crashed 1 castle at this point, we're probably not knocked too off kilter, and that should work also. So now we know we are ready to go. We are facing in the right direction. So now we just need to drive forward really far, right? So if we think about how far we need to drive forward, we know that our field is 2,000 millimeters by 2,000 millimeters. So if we're trying to drive diagonally across that, it's going to be a little bit more than 2,000 millimeters. So I'm going to take a guess at 2,000 millimeters here. Since I'm not exactly in the corner and then their castle is not exactly in the corner. Let's see if 2,000 will work. So let's give this a try. We're going to drive over to that corner castle, turn, we crash the second one and the third one. Look at that. We almost got that third one knocked down, but not quite. So I'm going to up that a little bit more going to add 200 millimeters to it and make it drive for 2,200 or 2,200 millimeters. And let's see if we can completely knock down that third castle. We turned, we drove, there we go. We drove again. Oh my goodness, look at how far those castle pieces went. We just did it together. We solved that mini challenge not one, but two ways. And I'm sure you can think of a bunch of other ways to solve that challenge. Well, guess what? That's what you are going to do next. You are going to explore all the ways to solve a challenge by trying to crash every single one, all 5 of the castles on this field. Before we do that, let's make sure that we save this project so this way you can come back and use this as a basis as you're working on your Castle Crasher challenge. So in order to save our project, we want to go up here where it says VEX-Code project, and we're going to type the name of our project in here. This project was to crash 3 castles. So I'm going to call it Crash 3 Castles. Now I'm naming it Crash 3 Castles. So this way, when I go to look for this project later, that name will help me remember what this project will do. So then I'll select Save. Now, in order to be able to use this project again, I also need to save it to my device. So I'm going to go over to the File menu and I'm going to select Save to your device. And here you can see that my Crash 3 Castles project was downloaded. So your project will go to wherever your device is set up to put its downloads. So now when I want to open up that project, I can select File and Load from my device. And then I can go to Downloads. And there's my project. So when I select Open, here is my very same project. So now that you have saved your project, now we know that we have a project that's ready to crash 3 castles. So now your challenge is to crash all of the castles on that playground. So you can add to the project that we started. You can make a whole new project if you want to, but your challenge is to find a way to crash all 5 castles on the playground. Once you've done that, make sure you save that project as Crash 5 Castles, and then come right back here and we'll talk about one of the many ways that we could solve this challenge. So how did it go? Congratulations on accomplishing your very first coding challenge in our Creativity in Coding Camp. Now let's take a look at one example of a way that you could have crashed all of these castles. So let's jump back into VEX-Code VR and I'll show you the way that I chose to crash all 5 castles. Your project might look similar, it might look different. That's fine. We can get a lot of different ideas from each other about different ways that we can sequence commands in order to crash our castles and make our robot solve the challenge. So here I'm going to show you one more time just how to load my Crash 5 Castles project. Now I saved my Crash 5 Castles project twice, so I'm going to open that one. And now every time we open that project, it will automatically open a playground for us as well. So now I can see once this opens up, let's take a look at what this project does. Now this project might look similar to yours, it might look different. Let's run it and we can see if you crashed your castles in the same order that I did mine. So I built on what we did for our Crash 3 Castles challenge and then drove in reverse and then all the way across the field to crash all of my castles. And I wanted my robot to go a little bit faster, so I upped that drive velocity all the way to 100%. I used a lot of different turn to heading blocks, and I ran my project a bunch of times to figure out exactly how far I needed my robot to travel or turn. So no matter how you solve the challenge, what matters is that you solved the challenge. As we learn more different ways to code, you may want to come back to these projects later on in camp and see if you can make them even more efficient or make your robot crash the castles even faster. You can keep iterating on this project. That's a really great word for adjusting and adapting your project to try to knock more of the castle pieces off of the field as you're running. So now that we've done our very first challenge together, it's time to learn about some even more amazing things that we can learn to do with our VR robot.
Hello, my name is Amy, and I'm another one of your VEX Camp counselors. So I know that previously you learned about what a programming language is and what behaviors are and how to sequence those behaviors to crash castles on the Castle Crasher playground. So now I get to share with you a new VR playground, which is the Art Canvas playground. So what you're going to do is follow along with me and learn to code your VR robot to draw on the Art Canvas playground. And it's a lot of fun. So let's get started. So the first thing you're going to need to do is to start a new blocks project. Of course, if your previous project is still open, you want to go ahead and save that project. But I don't have a project open, so I'm just going to do new blocks project. Then I am going to select this playground right here, the Art Canvas playground, and then select Open Playground, and my playground will load. All right. So as you can see here, we pretty much have what looks like a blank piece of paper, and we're going to code the robot to draw on it. Now, just in case you didn't notice this before, let's take a look at the robot from a side view so you can actually see the VR pen. So there's the robot pen right there in the middle of the robot, and that is what we're going to be using to draw on the Art Canvas playground. So there are a couple of blocks that we're going to be using in order to have our robot draw. And the first one is this block, which is the Move Robot Pen block. So I'm going to go ahead and drag it out here and attach it to my When Started block. And you can see it says Move Pen Down. We also have the choice to move it up if we want to, but since we're going to be making a line with our robot, we're going to go ahead and leave it on Move Pen Down. So go ahead and do that now as you're following along. And then the next thing we're going to do is have the robot drive so that it makes a mark. So I'm going to select a Drive For block, drag that out and attach it. Let me move this over just a little bit. Okay, now 200 millimeters isn't very long, so I'm going to go ahead and change my parameter in this block to 600, and then I'm going to run this so you can see what happens. So if I press the play button, there we go. Our robot drove forward for 600 millimeters and made a line on the Art Canvas. Okay, so I've made a mark with my robot. Let me reset the canvas right now, just like that. And what we're going to do now is add on to our project to have our VR robot drive a square. So far we've made one 600 millimeter line, so that can be one of the 4 sides of our square. Now we know that a square has 4 sides that are equal in length and 4 right angles, so that's what we're going to need to code our robot to do. So we've got our first side, but we're going to have our robot turn in order to draw the next side. So let's drag out a turn 4 block. And it's already set at 90 degrees, which would be the right angle that we needed to turn. So let's reset it and run our project. And it looks like we've gotten one side of a square, and then the robot is turned and ready to draw the next side of the square. Okay, what we could do is go ahead and drag out another Drive For block to make another 600 millimeter side for our robot and another Turn For block. But there's a faster, easier way to do it. So I'm going to put these back and show you this little trick. So what you can do is right-click on the top of the stack of blocks that you want to duplicate. You're going to get these menu options that open up for you, and then just select Duplicate. And it is going to duplicate all the blocks below the block you clicked. So look at that. Really quick, I've got another Drive For and Turn For a block just like the ones I had before, and I can add them to my stack. Now let's run the project and see what we're drawing. All right, we've got one side, now 2 sides of the square, and the robot is ready to do the 3rd and 4th side. So we can use that trick again, right? We need it to do the same exact thing, basically 2 more times. So I can go back to that top block in my stack, right-click, select Duplicate, and now I've got all of those blocks a second time that I can attach onto my stack and run them. Okay. 1 side, 2 sides, 3 sides, 4 sides. Fantastic. We drew a square on the Art Ring canvas. That is amazing. Okay, I want to show you something else that's really fun. So let's go back to the looks category of blocks, and then we're going to drag out another block. It is the set pen color block. So I'm going to put this block at the very top of my stack because I want to change the color from black to another color so that my robot can draw a different color square. So all I have to do is add that block. Of course, I want to do it before I start drawing, right? And I'm then going to choose the color. So I think I want to make a green square. And now when I reset my canvas and run my project, the VR robot is going to draw a green square. Okay. So now that you've learned how to code your VR robot to draw a square, we're going to try a little challenge, which is to draw 2 squares of 2 different sizes. So I'm going to reset my canvas. And here are the parameters for this challenge. Okay, we have to make 2 squares. One is going to be 600 millimeters by 600 millimeters, and the other is going to be half that size, 300 millimeters by 300 millimeters. Our 2 squares cannot touch each other. So we're going to need to pick up the pen in between drawing the 2 squares. All right, so let's see what we can do. Now we already have this project that draws a square for us, right? So let's run it one more time. What would we need to do then in order to draw a second square that's half that size? All right, moving the pen up is not the only thing that I need to do in order to get ready to draw that second square. I need to make sure my robot is facing the direction that I want it to face so that I can drive over into this empty space in order to make my second smaller square. So right now my robot is facing up. I don't really need it to be facing that way. What I could actually do is just take this last turn right block away so that instead my robot is facing the direction that I want it to drive. So let me show you what that looks like. Okay, so you can see since I removed that last turn 4 block, my robot is now facing the right direction, so I can have my robot use this space here to draw the smaller square. Now I need to figure out how far I want my robot to drive before it starts drawing the square. And I'm looking at this. I know this is 2,000 millimeters wide. I know that this line right here is 600 millimeters, so I can use that information to help me estimate how far I need to drive in order to be in the right position to start drawing my square. So I think if I don't need to do 1,000, right? That's a little bit too much. So let me go for 600, because if I drive 600 millimeters, that's roughly the same distance as one side of this square, and that's going to definitely give me enough space. Alrighty, so I'm going to get a drive for a block. I'm going to drag it over, and I'm going to change my parameter to 600 right here. And that will put me where? Let's find out. Yep, that should definitely be enough space. The last thing I need to do is turn my robot one more time so that it's ready to face the right direction. So I'm going to get another turn for a block and have it turn right one last time so that it's ready and facing in the correct direction. So let's look at that. As you can see, I'm testing my project as I go. I'm not trying to drag out all of the blocks to make both of these squares at one time. I'm doing one little chunk of coding at a time and then testing to see if the robot is behaving as I want it to behave. That is a much easier approach than trying to figure out where you made a mistake after you've gone ahead and coded a huge, long project. So that is what I recommend. All right, our robot is definitely ready to start drawing, so that means I can move my pen back down. So let's get another move robot pen block, and it's set to down. Now I could also change the color if I wanted to. I'm not going to do that, but if you want to, you can. My pen is now down, and I know how to draw a square. I've already figured it out. So I'm trying to draw a square that is exactly half the size of the square that I already drew. And since my first square's sides were 600 millimeters long, If I cut that in half, it's 300 millimeters. So that's what I'm going to do. So I'm going to go back to my drivetrain category. I'm going to get my drive for block, add it on, and change my parameter to 300. And I know I'm going to need a turn for block as well. All right, let's give this a little test. Here's our first square. Our pen is up, we're in position. Here's one side of our second square. Great, this looks great. Okay, now we already learned our trick to duplicate blocks, so we're going to use that again because why not? So let's right click, duplicate this for the second side of our square, and then I'm going to go ahead and do the same thing again for the third and fourth sides of my square and add those blocks to my stack. All righty, here's the test. Let's see if we've met the challenge to draw two squares of two sizes that are not connected. Here we go. We've got our first square looking good. Here goes the second one side, two sides, three sides, four sides. Look at that. We did it. All right, we did it. We have made two squares that are exactly one is one half of the size of the other, and they're not touching each other, so we have met the challenge. Okay, so we've learned how to use the Move Robot pen block and the Set Pen color block to draw on the art canvas and change the color of the pen. And we've drawn squares of two different sizes. So now what you're going to do is we're going to learn how to use loops to draw a square or code our robot to draw a square in a more efficient manner. So the first thing I want to do is get my project back to the point where it's only drawing one square. So I need to move the blocks off of there that draw the second square. So I'm moving them over here to the side. And as you recall, at the end of the stack of blocks, there was another turn for block. So I'm going to go ahead and put that one back on there. And now I'm back to that original project. So let's just run it one time to make sure that we are where we need to be. And we do have our original square. Okay. Yep. We're good. So as you can see here, we have our drive for and turn for blocks 4 separate times here in order to make the pattern that allows the robot to drive in a square. But what we're going to do is simplify this, and we're going to start by removing all but the first 2 blocks in that pattern. All right, I'm going to put them aside here. And then I'm going to go over here into my control section, and I'm going to get a repeat block and drag this repeat block out. Now what I want to do with this block is put it around the blocks that I want to have the robot repeat. So I'm going to actually drag it around those blocks, and see that little gray shadow that's appearing? It's showing me that those blocks are now going to go inside this repeat block when I attach it to the Move pen block. So there they are, they're inside that C-shaped block. So right now I have the repeat block set at 10. This is my parameter right here. And I'm saying right now that it's going to repeat 10 times. I don't need my robot to drive forward and turn right 10 times. I need my robot to do it 4 times because this is a square. So I'm going to change my parameter to 4. I'm going to reset my canvas here, and let's run it and see what happens. If you're watching the green highlighting, you can see that it's highlighting that little sequence of drive forward and turn right 4 different times. So what we have now done is made a loop. Okay, so in our loop, what we've done is set a condition in this repeat block, because loops have conditions. And the condition here is that these 2 blocks must be repeated 4 times before anything else can happen in this project. And we can really illustrate that by adding some more blocks to the bottom. So if I go into my looks category again and get my Set Pen color block out here and change it to red, and let's just draw another line. So let's imagine we wanted to draw another line. I'm going to do drive in reverse for 600 millimeters. So we're going to make another line after we draw our square. And then let's watch the project flow as we run this project. So here we go. It's gone down into the repeat loop, repeated 4 times, and now it can move on to the next block. And that's how it works. Okay, so let's think about everything you've learned in this section so far. You learned how to use the Art Canvas Playground. You learned how to use the Move Robot pen block to set the pen color. You've learned how to use a loop to simplify and make your code more efficient. And now you're going to try to draw an entire house using the Art Canvas. Let's take a look at what that would look like. So what you're going to do in this challenge is use blocks from the drivetrain, looks, and control categories in the right order, correct sequence, to draw a house on the Art Canvas Playground. It's going to look something like this. So what you're going to do right now is go ahead and start a new project or modify your existing project and have code the VR robot to draw a house similarly to what we just looked at. Don't worry if you don't get it the first time. Of course, you can always iterate and try again. And when you're finished coding your robot to draw the house, come on back here and we'll take a look at one possible solution. Congratulations, you have coded your VR robot to draw a house on the Art Canvas Playground. How cool is that? Let's take a quick look at one possible solution that you could have used to create your project. Of course, this is just one of many possible solutions to drawing a house with your VR robot. You could have chosen different angles. You could have chosen different colors. There's so many different ways to do it. And that's one of the things that makes coding so creative and so fun. So congratulations on completing the Draw a House challenge. You've learned to use the pen on the VR robot, and that is amazing. If you want, you can go ahead and add some more details to your house, change the colors, add some fun features. It's up to you. Enjoy being creative with your coding, and we'll see you back here soon.